details of chapter number 13. The name of the lesson is surface area and volume of solids. So let's go to the first type of solid. We have a cuboid here. In a cuboid we have three sides. The longest is called the length, the shorter one is called the breadth, and the shortest is termed as the height of the cuboid. As you can see, a line that joins the opposite end points, okay, that's called the diagonal. There are a few formulas related to cuboid, that is the total surface area of the cuboid. If you find it, you use the formula 2 into length into breadth plus breadth into height plus height into length. If you want to find the curved surface area, okay, then use the formula 2 into height, length plus breadth. If you find the volume, that is the quantity of matter inside the box, the formula is length into breadth into height. If you want to find the diagonal of the cuboid, we use the formula length square plus breadth square plus height square and root of all that. Let's go to the second figure. We have a cube. Most of you play snake and ladders in that you use dice in the shape of a cube. In a cube, rather than having all the different sides with different lengths, here we have the sides with the same lengths. As you see, I have written A, and A. So sides are of equal measure, and we have the diagonal here. To find the total surface area of this cube, the formula is 6 because we have 6 faces here. 6a square. If you want to find the curved surface area, then you use the formula 4a square. If you want to find the volume, that is the quantity of matter inside the box, that is equal to a cube. And to find the diagonal, you will use the formula of root 3 into a. Moving to the third figure, that is the cylinder. In the cylinder, as you can see in the figure, we have a height, and from the center, that is, if you see the top and bottom of the cylinder, it is the shape of a circle. So from the center to end point of the circle, you see the mark of radius. If you want to find the radius of the base or the top of the cylinder, the formula utilized is similar to the area of a circle, pi r square. If you want to find the curved surface area, that is the perimeter and the height, the formula is 2 pi r h. If you want to find including the area including the top and bottom, the total surface area, the formula is 2 pi r h plus r. If you want to find the volume, volume means if I fill oil or any liquid inside or sand inside it, I want to find the volume of the cylinder, I use the formula pi r square h. Moving ahead, we go to a similar type of structure of a cylinder, but here the cylinder is hollow. You can take an example of a pipe through which water passes. Okay. Here you can see two radiuses, a small radius and a bigger radius, and height is common for both the parts of the cylinder. If you want to find the area of the base or area of the top of the cylinder, the hollow cylinder, you use the formula pi in bracket r square minus r square. Okay, capital R minus small r. You can make changes out here. If you want to find the outer curved surface area of the cylinder, outer portion of the cylinder, you use the formula 2 pi r h. It looks quite similar to this one. If you want to find the inner curved surface area of cylinder, you will again use the formula 2 pi r h, but here you have to take the smaller radius. Now total surface area of cylinder, see the difference between this and this is only the addition of the radius. Okay, 2 pi h r plus r. If you want to find the total surface area of this hollow cylinder, the formula will be 2 pi r plus r in bracket h plus r minus r. Remember this formula. If you want to find the volume, you can see the difference here. The difference is only of the radius. There is a difference of radius square in the bracket. Here is pi r square h. As you have a single radius, in a hollow cylinder you have two radiuses. So you write pi h in bracket the larger radius square minus the smaller radius square. Solid figure that we see is a cone. Okay, as you can see, cone has three dimensions out here. One is a straight height, the other is a diagonal, that's termed as a slant height, and the radius, the distance from the center of the circle to anywhere on the circle at the base. An angle formed here at the vertex is termed as the vertical angle, okay, of the cone. And if you want to find a total surface area of cone, the formula used will be pi r l plus r. If you want to find the curved surface area of the cone, the formula is pi r of the circle and l, that is the slant height. If you want to find the volume of the cone, if you fill anything inside it, the formula is 1 upon 3 pi r square h. And if you want to find the diagonal, that is the slant height, use the Pythagoras Theorem. N is equal to to either under root of r square plus n square or n square is equal to r square plus n square. Now remember, in the questions you may get any of these values. You may also get the slant height and the radius. You may also get the slant height and the height of it, then you find the radius. So you have to interchange the place of these and subtract any of these values with the slant height, square of slant height. Moving to sphere, it's a round shaped body, okay, having only one dimension, that's the radius. If you want to find the curved surface area of the sphere, the formula is 4 pi r square. To find the volume of it, you use the formula 4 upon 3 pi r cubed. If I break the sphere into two equal halves, it becomes a hemisphere. Again, it has the same dimension, radius. If I want to find the curved surface area of it, you use half of this. If you see here, 2 pi r square. To find the total surface area of it, including the top, it will be 3 pi r square. If you want to find the volume of it, the formula is half of this, 4 upon 3, that is 2 upon 3 pi r cubed. Now, many a times we will have objects which will be like a spherical shell. It will have two radiuses, the inner dimension radius and the outer one. If you want to find the outer curved surface area of this, then obviously the formula is 4 pi r square, equivalent to that one. If you want to find the inner surface area, formula is once again 4 pi, but here you will take the internal radius of it. And if you want to find the volume of it, you use the formula 4 upon 3 pi. If you see this formula and this formula, there's only a difference between the radius. Here we have two radiuses, so there's a difference mark here. There is only one radius.